Welcome to Frontier. We have an efficient team to work with your data to provide better insights as we strongly believe what gets measured gets improved. Hi guys, I feel glad to welcome you all to my next video. Let's start with a small recap of my last video. In our last video, we saw a brief introduction to the path of statistics. Say, what statistics is, the difference that lies between statistics and the probability, what are its types, and what descriptive and inferential statistics is all about. As I promised you guys in my previous video that I'll make you clear with the two most important topics that contains many vital statistical jargons is measures of central tendency and measures of dispersion. Are you guys pretty excited about what they are? Let's dive into it. Before getting to know about the measures of central tendency and measures of dispersion, each and every measure can be applied to two different variables. That includes discrete random variable and continuous random variable. Discrete random variable usually takes a precise numerical value, whereas continuous random variable takes a value between the intervals or range or span of values. Now let's move into measures of central tendency. The measures of central tendency usually identifies the central position of the given data set. It summarizes the data through mean, median, and mode. The measure of central tendency is all about playing with these three M's. Now let's clearly see what these three are. Mean is the first measure of central tendency. Mean is considered to be the best measure of central tendency as it takes into consideration every data points while calculating it. Arithmetic mean holds two different formulas for two different variables. Arithmetic mean for discrete variable is calculated as taking the sum of every observations divided by the total number of observations. While for continuous random variable, the numerator takes the product of frequency and the middle value of the class interval, whereas the product of frequency is denoted by f and the middle value is denoted by x, while the denominator is the total number of observation. There are different types of mean which includes geometric mean, weighted mean and so on. The next M comes median. Median points out the middle value of the dataset. To find out the middle value, we need to sort the data points either in ascending or in descending order. In case of odd number of total observations, the median is n plus 1 by 2 value. That is, consider the series 2, 3, 5, 7 and 11. Now we have total number of observations as 5. So that is odd. Now it will take the formula 5 plus 1, that is 6 by 2, third value. So in our series the third value will be 5. So the median for this case is 5. In case of even number of total observations, we can find the median by taking the pair of middle numbers and take average for it. So consider the series as previous 2, 3, 5, 7, 11. Here we are going to add one more digit 13. So here our total observations is 6, that is even. Here the middle pair of numbers are 5 and 7. So take average of it. 12 by 2 6. So in this case 6 will be your median. The next M is mode. Mode is the measure which finds out the value that most often occurs in the dataset. It is not surprising that the dataset can have more than one mode. That is, two values can occur with equal higher number of frequencies. It is known as bimodal. Even more than two numbers can have same number of higher frequencies and it is known as multimodal. Sometimes the dataset can even have no mode. Next comes measures of dispersion. Measures of dispersion is used vital in knowing the extent of variability in a data, where the measure of central tendency fails in this. The four commonly used measure of dispersion are range, quartile, standard deviation, and variance. Range is known to be the simplest measure of dispersion as it is computed very easily. The range is usually defined as the difference between the maximum and the minimum value of the data. The range usually gives the variation within the data itself, and it does not involve the variation from any measures of central tendency. The range is not much effective because it doesn't take into consideration the every data points. It only takes into consideration the extremes. It is also much affected by the outliers. Outliers is nothing but a data point that differs significantly from other observations. Range usually takes the formula maximum value minus minimum value. For example, consider the sequence of numbers from 1 to 100. Its range is 100, that is maximum value, minus 1, that is minimum value. So range will be 99. Quartiles. Quartiles usually divide the data into four halves, that is, four quarters as Q1, Q2, Q3, and Q4. It is independent of the extreme values. Usually, each quarter consists of 25% of the data. Hence, once the data points are sorted, Q1 consists of first 25% of the maximum values in the data, and likewise, other quartiles will follow the descending order. Interquartile range is defined as the difference between the third quartile and the first quartile. Symbolically, it is represented as Q3 minus Q1. Standard deviation. Standard deviation is considered to be the best measure of dispersion. Can you guys remember what is considered to be the best measure of central tendency? Yes, it's mean. It is considered to be the best measure of dispersion as it gives the deviation of each data point above the arithmetic mean of central tendency, and it normalizes the deviation. Hence, it gives us the absolute measure of value. The value of standard deviation is always positive as it generally takes the positive square root of the deviation as given below. The standard deviation takes the formula square root of summation of the data point, that is x, minus its mean, the whole square, by n minus 1, where n is your total number of observations. Variance. Variance also gives the deviation of the observations from mean, and it is generally calculated by squaring the standard deviation. It means it doesn't have any square root in the formula that we seen in our previous slide. Standard deviation is generally or practically used to find out the deviation of the same dataset, while variance is used to find out the significance of deviations between two datasets, which is known as ANOVA, that is, analysis of variance, which will be explored clearly in my succeeding videos. Hope you guys now got a clear idea about the measures of central tendency and the measures of dispersion and its jargons. Thank you guys. We'll meet up in my next video. Bye.